Imagine standing in a prehistoric jungle, the air thick and heavy with the scent of cycads and ancient pines. Life is everywhere, from the hum of insects to the rustle of sauropods, passing a world of giants, untouched by the future. Suddenly, without warning, the world changes. The sky doesn't just ignite, it seems to shatter, and within hours, the earth becomes a tomb. This is the story of that day, a day that ended an era spanning 165 million years and gave rise to our own. 66 million years ago, our planet was home to some of the most fearsome and majestic creatures ever to walk the earth. Dinosaurs were not just big. They were a diverse, globally dominant supergroup, ranging from chicken-sized microraptors to the immense long-necked Argentinos. This was the late Cretaceous period, the golden age of dinosaurs, a time when evolution had perfected its grandest designs. Species like Tyrannosaurus rex, Triceratops, and the feathered velociraptors were not just apex predators. They were the culmination of a long evolutionary success story. The continents were in different positions. Then the Atlantic Ocean was narrower, and Earth's climate was a warm, humid greenhouse. Lush, tropical forests stretched across the globe, and flowering plants had just begun to spread, creating a more modern-looking ecosystem. Life was booming, teeming with an intricate web of creatures great and small. Yet it was all balanced on a knife's edge. And one object, a colossal rock 6 miles wide, would unbalance it all in the span of a single minute. The killer was a massive asteroid, or possibly a comet, a rogue from the outer reaches of the solar system. It had been orbiting the sun for millions of years, an invisible bullet in a cosmic game of chance, until its path finally intersected with ours. It hit the Earth near present-day Chicxulub, in the Yucatan Peninsula of Mexico, a fateful point in space and time. Scientists estimate it was moving at an unimaginable velocity, 20 kilometers per second, which translates to over 45,000 miles per hour. At that speed, it would have crossed the entire width of the Atlantic Ocean in just 10 minutes. But it didn't need 10 minutes to destroy a planet. It needed less than one to set a cascade of destruction in motion. The impact released an energy equivalent to more than 100 teratons of TNT, a number so vast it's hard to comprehend. That's over 1 billion times more powerful than the atomic bomb dropped on Hiroshima, and orders of magnitude more powerful than every human-made weapon combined. The asteroid slammed into the Earth's crust, instantly vaporizing rock, water, and every living thing for hundreds of miles around. The heat at the impact site reached temperatures hotter than the surface of the sun, vaporizing all matter into plasma. The resulting crater was over 110 miles wide and 18 miles deep, a wound in the Earth so profound it left a permanent gravitational anomaly. To this day, the Chicxulub crater remains buried beneath layers of sediment, its ghostly outline only discovered by geologists in the 1970s. Within moments of the impact, billions of tons of molten rock, dust, and superheated gas were blasted into the atmosphere. Some of it was ejected with such force that it escaped Earth's gravity entirely and entered space. The rest came raining back down. This falling debris, now re-entering the atmosphere as fiery projectiles, heated the air to thousands of degrees. The entire planet's atmosphere briefly turned into a colossal oven, igniting a firestorm that consumed nearly every forest on Earth. Evidence of these ancient fires is preserved in a thin layer of soot, a black line in the geological record. This layer, found in rocks across every continent, marks the boundary between the Cretaceous and Paleogene periods. It's known as the KPG boundary, and it's filled with a rare element called iridium, a smoking gun for a cosmic impact. Iridium is virtually absent in Earth's crust, but is abundant in asteroids, proving that this was no ordinary volcanic event. Scientists believe these wildfires raged for weeks or even months, transforming lush forests into charred landscapes. Animals caught out in the open, like the great sauropods, died quickly, while those underground or underwater had a better chance. But fires weren't the only threat. The initial shockwave triggered massive earthquakes, some estimated at a magnitude of 11 or higher, and megatsunamis. Some waves reached heights of 300 feet, traveling across entire oceans and devastating coastlines worldwide. In some places, these waves left behind massive piles of marine debris and fossils far inland. In the Gulf of Mexico, sediment layers show evidence of tsunami deposits over 1,000 miles from the impact site. Meanwhile, in the atmosphere, ash, dust, and sulfur aerosols spread globally, blocking sunlight for months or even years. This plunged the world into a prolonged impact winter, a cold, dark period with freezing temperatures that decimated plant life. Photosynthesis ceased. Plants died en masse, a global famine that was instantaneous. Without plants, herbivores starved, and without herbivores, the great carnivores followed, doomed by the slow collapse of their food source. The food chain didn't just snap in a few days. It unraveled over months and years, a slow and agonizing demise. Some species may have hung on for decades in dwindling numbers, before eventually vanishing forever. Marine life also suffered catastrophically. Plankton, the very foundation of the oceanic food web, nearly disappeared. This led to the extinction of many marine reptiles, ammonites, and countless other sea creatures that relied on them. When it was over, an estimated 75% of all species on Earth had gone extinct, a reset button for life on our planet. The non-avian dinosaurs, everything from raptors to sauropods, were completely wiped out. Their reign ended in a fiery climax. Pterosaurs, the magnificent flying reptiles, also vanished, leaving the skies empty for new life forms to take their place. So did the mosasaurs and plesiosaurs that dominated prehistoric oceans, their massive skeletons now a testament to a world lost. Yet some life endured. Crocodilians, turtles, frogs, small burrowing mammals, and birds managed to survive by being adaptable, small, and able to hide or hibernate. Birds? Yes, birds are the direct descendants of small feathered dinosaurs, the lineage that continued the dinosaurian legacy. So in a way, not all dinosaurs died. Some still chirp and fly among us today, the living reminders of a lost world. One of the most fascinating fossil sites linked to this event is in North Dakota, at a place called Tsunamis. Here, paleontologists uncovered a scene frozen in time, a graveyard of animals that died within hours of the impact. Fossilized fish with tektite's tiny glass beads formed from impact debris lodged in their gills were found, suggesting they were alive when the debris rained down. Nearby were charred tree trunks, dinosaur footprints, and a perfectly preserved dinosaur leg with its scaly skin still visible. This site paints a haunting picture, animals dying not weeks later, but in the very moment the Earth was changed forever. It's one of the most compelling and detailed records of mass death in the fossil record. The asteroid itself may have struck the worst possible place on the planet. The Yucatan Peninsula is rich in sulfur-rich limestone, which vaporized into a gas upon impact. This sulfur mixed with water in the atmosphere, forming deadly sulfuric acid aerosols that reflected sunlight and poisoned rainfall. These aerosols accelerated climate collapse, making the impact winter far more severe than it would have been otherwise. Had the asteroid hit oceanic crust, like in the Pacific Ocean, the outcome might have been less severe. But its unfortunate landfall location made it the perfect extinction weapon, a geological strike of cosmic proportions. Today, the asteroid theory is supported by decades of robust evidence that has transformed our understanding of planetary history. The KPG boundary, the Chicxulub crater, the global soot layer, and shocked quartz crystals, they all tell a consistent, undeniable story. It took scientists decades to piece together the puzzle of the dinosaurs' demise. And it all started in 1980, when Nobel Prize-winning physicist Luis Alvarez and his son Walter proposed the radical asteroid theory. For a time, the idea was controversial, seen as a fringe theory by many in the paleontological community. But as more evidence mounted, it became one of the most well-supported and widely accepted extinction events in Earth's history. But here's the chilling part. This wasn't the first mass extinction, and it won't be the last. Earth has faced 5 major mass extinctions in its history. The KPG was just one of them. And asteroids are still out there, a constant threat from the cold blackness of space. NASA monitors thousands of near-Earth objects, but many smaller ones remain undetected, like needles in a cosmic haystack. In 2013, a meteor exploded over Chelyabinsk, Russia, with the force of 30 Hiroshima bombs. It shattered windows across 6 cities and injured over 1,500 people, and it was only 66 feet wide. Now imagine one a mile wide or 6 miles, like the Chicxulub asteroid that silenced the dinosaurs. We'd have mere hours, maybe minutes, to react to such a threat. That SY planetary defense has become a growing and urgent concern for scientists and governments around the world. NASA's 2022 DART mission marked a monumental milestone by successfully altering the path of an asteroid. For the first time in history, humanity proved it could change the course of a celestial object. It was a small step, but a monumental one step that could make all the difference someday. The dinosaurs had no warning, no way to prepare for the end. But we do. The story of their extinction is a tragedy, a cosmic stroke of bad luck that ended a beautiful era of life. But it's also a powerful lesson, a lesson in vulnerability, resilience, and cosmic humility. Because in the end, it wasn't size or strength that determined survival. It was adaptability, luck, and a place to hide when the sky fell in on them. And now, 66 million years later, the descendants of those tiny, burrowing mammals rule the Earth. We owe our existence to the very same event that ended the reign of giants, a paradox of life and death. The day the dinosaurs died was not just the end of an era. It was the brutal, violent beginning of our own. The beginning of mammals, of primates, and eventually of us. Their ashes became our soil, the foundation of the world we inhabit. Their fall, our rise. But make no mistake, the cosmos hasn't stopped moving, and the odds of another impact haven't been eliminated. Another rock could be out there right now, tracing a silent, invisible path toward Earth. Will we be ready? Or will we join the fossils beneath the KPG boundary, lost to time? The dinosaurs never saw it coming, but we can. And that makes all the difference in the world.